Problem 11 says the chart below contains information about a function f and its derivative. Assume that f is differentiable on -2 to 1 included and use the charts to answer the questions that follow. So the first part says determine the linearization of f at -1. So the formula for linearization is based off the equation of a tangent line. So we say L of x equals f of a plus f prime of a times x minus a. So notice this is based off of, we can write this in a different notation saying y1 plus m times x minus x1. So it is taking the point slope formula and adding the y1 to both sides. So we write it in both ways. This is the same exact thing. So for our problem, our a value is -1. So f of a, if we pull it off the chart, is going to be f of -1, and f of -1 is 2. F prime of a, or our slope, is going to be f prime, of -1. And if we go off this chart, we see that it's -1/3. So now we're just going to plug it into our equation. So L of x equals 2 minus 1/3, because it's plus a -1/3, times x minus 1. And you can stop right here. We don't expect you to simplify it any further than that. Part B says, well, now use your linearization to estimate the value of f of -1.5. So that simply means plugging -1.5 into our line. So 2 minus 1/3 times -1.5 plus 1. And you can stop right here. You don't have to take this any further. We just need you to know that plugging it into the line is how we estimate that value. C says, well, suppose we know that f prime is continuous on -2 to 1 included. Explain why the graph of f must have an inflection point somewhere on the interval from -2 to 1. So this one can be a little tricky. So if we remember, inflection points are where the second derivative, that should be an x, equals 0. Or we need to look where f prime changes from increasing to decreasing, or from decreasing to increasing. So this is how we would determine this. So based on the table, just by looking at the values, it may be tricky to figure that out. So one thing you can do with your derivative is we can plot those points of the derivative function, because we actually saw in an earlier problem we can actually know how to read the derivative graph. So I'm going to plot these values and see what my picture looks like. So at -2, we're at -1/8, which is going to be somewhere down here. So this will be -2. At -1, we're at -1/3. 1/3 is a larger number than -1/8, so it's going to be a lower value. At 0, we're down at -1. And then when x equals 1, we're back up at 0. So if I just sort of loosely connect these lines, I don't know exactly where that turning point is, but it's very, very clear from the picture that the derivative function decreases and then has to increase to get back up to 1. So somewhere between here, there's got to be an inflection point, because the derivative has to be 0 at that turning point. So we can now state that based on the chart of f prime, there must be an inflection point on f on the interval of -2 to 1 since f prime changes from decreasing to increasing at least once. So another way we could do this if we had a function is we could look at the first derivative test, and you would see that these would be negative signs. The derivative is decreasing, right? And then over here, even though the derivative is still negative, we would see the values going up. So the function is, the derivative values are getting smaller, and then they start getting bigger again, so there has to be some kind of turning point on the derivative function, and a turning point on f prime would mean that the second derivative would be 0 at that location.